outside India, because India is a vast country. A lot of agri institutes were buying very costly instrument from outside India, and this is when Rajiv and me visited one of the institute in Pune, and we thought, okay, this can be done in India. There's nothing too much. It's not that much complicated, and this can be done in India. We started with weather monitoring devices very specifically for floriculture business in the Hosur belt. Later, because that was too much early, there was not too much uh, there was not too much happening in the agri-tech field in that time. So we pivoted to the full stack IoT solution. But again, later down the line, we thought, okay, it's not happening because you cannot diversify yourself too much with a small team. So we again came back to the agri as a vertical, and we start deploying solution for both pre-harvest and post-harvest. Down the line, we dropped post-harvest because again, same thing, that being a small team, being a startup, you cannot be going everywhere. You will not develop any expertise in a specific vertical. Whereas being a startup, you have to always develop expertise in very specific field, in very specific vertical. You have to keep on hitting the nail again and again, and that is when you will be known in the field for doing something. That not every means you don't want to become a service company for agriculture or for IoT. So this is a brief introduction about Yuctex technologies. I'll jump to the IoT part of that. So the first point that was given to me was role of IoT in agriculture. So what role does IoT play in agriculture? I did some research. Sometimes I understand everything what is happening in agriculture or in IoT in agriculture, but sometimes it's a bit difficult to explain to people that what in general is the role of IoT in agriculture. So, as per me, the role of IoT in agriculture is to monitor, manage, and control. Now, there are multiple things to be monitored, right? It depends upon your use case. If you are in post harvest, you can be monitoring methylene, ammonia, CO2, temperature, humidity. If you are in pre harvest, you can be monitoring air temperature, air humidity, rainfall, wind speed, wind direction, leaf wetness, soil moisture, soil electrical conductivity, soil temperature, solar radiation, right? So there are multiple variables that can be monitored. It always depends upon your use case. So while talking about the role of IoT in agriculture, I have divided this thing into three parts. First is monitor, second is manage, and then third is control. So we can monitor different variables, whatever sensors are available in the field. Based upon your use case, you can monitor different variables. Now you have to manage those variables and probably you have to control those variables. Manage as per me is that you need to know about what is happening in those variables, and then you can take some corrective action. For example, if you have set the if you want to maintain a temperature of 6 degrees centigrade in a cold storage, right, you need to know first that okay, is it going above 6 or is it going below 6, right? And then you can control. So what you can manage, you can manage and control internal environment, you can manage counting of livestock, you can manage soil moisture, you can manage dissolved oxygen, you can manage pH of water and fisheries. So as per me, the role of IoT in agriculture is consist of these three things: monitor, manage, and control. Going forward, a role of IoT in agriculture. So again, this is where I am trying to deep dive again into IoT more. So same thing. You can divide the IoT into three parts again. First is the monitoring part. Second is store, computation, analytics, the backend side, and third is the advisory and decision making, the front end side. What farmer usually see, right? So here, same thing. I'll probably discuss more on that. That in the monitoring, there are a lot of verticals that I have discussed with you in the previous slide. There are different variables that you can monitor. It always depends upon your use case. Not all the variables can be monitored because there might not be sensors available for all the variables, right? So it depends upon your use case. When it should be monitored, continuous sensing is not required in certain cases. For example, uh, the soil characteristics like pH, EC, pH, EC, soil carbon, NPK, they don't vary too much fast, right? They might vary after 15 days when you do the fertigation or after a season, right? So there are certain variables that need continuous monitoring. There are certain variables which don't need continuous monitoring. It will be waste if you monitor them continuously, right? Now, where to monitor, right? A lot of people ask me this question that when you are monitoring soil moisture, how many sensors are required 5 acre or how many sensors are required in 1 acre, or how many sensors, how your weather station can cover how much big area, right? So it always depend upon the location, it always depend upon the instrument. So this is probably where. Now how, so how you can monitor. So for monitoring you need sensor, you need devices, right? I will come to that part of sensor and devices. Now, second part of the IoT in agriculture can be storage basically. So your IoT devices sense this value, they send it to a cloud using any kind of communication option. That communication option can be 4G, that can be Wi-Fi, that can be sub gigahertz communication, right? They store it in the backend, then they do the computations. Computations can be computation, they do the analytics, and they store the output in the backend side. Now, whatever computation, whatever analytics has been done, this has to be sent to the user. Now again, the same question come over here also. What kind of advisory you want to send to the user? The advisory can be weather forecast. The advisory can be disease and pest insect forecast. The advisory can be when they should be doing irrigation, how much irrigation they should be doing, or how much liter per plant they should be doing the irrigation, right? Now, second thing is saying when. So this is again same thing that you don't want to overload the user. If you send a user 10, 20 advisories in a day, they might not be interested. So you have to make sure that you are sending them the advisory which they are interested in. Now, third question is again same. Who is the user over here? The user can be farmer, and the advisory for the farmer can be different as per the advisory for the FPO. The user can be FPO management. User can be self-help groups, or user can be B2B companies also. So whatever information or advisory you are sending to the user varies from user to user. For example, a management in B2B might not be interested in knowing what is happening at individual cold storage or what is happening at individual field. They will be interested to know what is wrong happening in a specific particular area, right? Now the fourth point is again how. So the advisory can be sent through SMS, through call, through app, Android app. That can be Android or iPhone app. It can be sent through web app, WhatsApp basically. It can be sent through web app basically also. So again, the idea behind talking about the role of IoT in agriculture is that okay, how it will help the agriculture by monitoring, manage, and control. And then in monitoring, manage, and control, what are the three? What can be the components basically? So components are basically monitoring, storage, computation, advisory, and decision making. Now, continuing the same thing, this is more about IoT in particular. That when people say, "What is IoT?" So I have been repeating this term from long back that IoT is nothing but an umbrella term for a lot of technologies, right? In the very early days in 2010, when we were doing engineering, we simply called it as embedded system design, right? Now, down the line, when this 4G or 2G communication start picking up the pace, people added this 4G communication. So this is nothing new. Means people have been tracking their trucks using GPS from long back. Means in fact, I have heard in 2005 also that people were tracking, but the number of devices were very much low because we have not reached a point in the technology where everything was very cheap. The first microcontroller was introduced in IIT Kanpur in 1985, and the way they were doing programming of that controller was very different the way we are doing programming right now, right? So things have moved also. So I will spend probably a couple of minutes over here that what does IoT constitute of? So the IoT constitute of sensors. Sensors can again sense. There are multiple kind of sensor which can provide you output either on analog or digital basically, right? Then basically you need some kind of chip that can take value from that sensor and interpret it, right? Sensor provide output, as I mentioned, sensor provide output in digital or analog. Analog can be current or analog can be 0 to 5 volt or 0 to 3 volt, but then do means you have to convert that voltage into something that a machine that probably user can understand, right? User will never understand 2 voltage in terms of soil moisture. They will understand in terms of percentage, volumetric water content on basically HP or pressure based upon sensors, right? So you need a hardware which can take output from sensor. You need firmware. Firmware is more like the software that reside in the chip or in the hardware that basically manipulate the voltage into something readable. Then you need communication modules. The communication, so you have sensor, you have a chip, you have firmware written on the chip, you have communication module, 4G or Wi-Fi or sub-gigahertz in terms of Zigbee or LoRa or NB-IoT. So these components make the IoT devices. You have sensors, you have hardware, you have firmware, you have communication module. They all make the IoT device. Now, what does this IoT device will do? It will sense the variable. It will send it to cloud using the communication module. On the IoT cloud side, you need to manage your devices. You need to manage your data because these IoT devices can even send data every 1 minute or can send data every 1 hour. That depend upon you how you have programmed, right? So you manage these devices on the IoT cloud. You manage these devices data on the IoT cloud. You do computations, you do reporting, you do alert. Then you should have a API machine. API machine is nothing but interface between the front end, what you see on the web browser, and the backend, right? So all those who are from the who have some understanding of how the software work, they will understand. To those who don't understand this thing, so this is more like how what you see on the web browser, how that is interacting with the cloud server. That is more like a API machine. And the front end side can be again same thing, web, smartphone, and application. These are some basic component of IoT. Uh, Now, what kind of process is involved in developing these IoT devices? So this might be interesting for those who want to start their IoT startup, or who want to manufacture their IoT devices for some of their use cases, right? So first of all, you need to understand that what is your requirement, what kind of variable you want to sense. You have to research in the field that whether that sensor is available or not, right? Based upon that, you need to select some components. Means component is sensor selection, and what kind of microcontroller or microprocessor will work for you, right? There might be scenarios where you want to go total off grid, and there you need to have a device that consume less power. So you need to select your microcontroller based upon that requirement. A controller that consume nanoampere or microampere and can still run while in sleep mode, right? Then you need to develop a schematic diagram. Once the diagram is completed, you will give it to somebody who will convert that schematic diagram into Gerber files. Then you will figure out some fabrication guy, PCB fabrication guys in India. There are multiple of them. PC Power. There are few in China also, to whom you can send the Gerber file and they will give you back the PCB. Then you will order the component through online. Mouser is there. DigiKey is there. Once the order comes to your office, you need to get them assembled. There are multiple assembly providers also in Bangalore or everywhere in India. Once that is done, so you have your fabricated PCB, you have component mounted on them. Then you need to put that PCB inside an enclosure to make. If you are going totally off grid or in outside environment, you need to make sure that your enclosure is IP67 dated. It can withstand harsh environment, right? And then before that, basically, you need to put the firmware inside on the PCB, firmware the software part. You need to do testing, and then you can go for deployment. So these are the few steps that are involved when anybody is doing any kind of IoT device. This is more on the soft IoT management layer. This is more in the IoT management layer. This is a bit more complicated. That on the backend side, you need to have a TSDB, that is time series database. You cannot simply store your IoT devices data into a normal database. Then you need to have a IoT device infrastructure management also, as in how many devices are up, last ping time, when somebody has pinged, what is the processing time, how many users have logged in, backend process monitoring. You can have account in account, you can have device, you can have different channels. Basically, channel is nothing but a sensor type. A device can have different kind of sensors, right? So this is how any IoT manufacturer or any IoT service provider will manage their backend. You can group different devices. For example, a farm can have 10 devices also. You need to group them, and the user can say, okay, 5 devices go into this field, 5 devices go into this field. So you need to have a system in which you can group these devices and assign devices to a farm or multiple farm. You need to run different computations. So data is just one thing. And farmer is not very much interested in how graph is growing or how graph is looking. They are more interested in what they should be doing on a specific day. So you need to run different computations on the sensor data, right? And then there can be different dashboard. A dashboard can be different for farmer. The dashboard will be different for B2B management or of the dashboard will be different for a FPO, because FPO, for the FPO they need to interact with farmers, right? You need to provide multiple language support. You need to control the user access. You need, there can be different user in in the similar dashboard, and then there can be different data processing pipeline. I will not go deep into this because then it will take too much time. I want to go to the application side next. This is the kind of dashboard that you can have. This is more like the backend dashboard, which allow us to create different farm, different users, and this can be one Android application interface that you can that probably your user might be using. Now coming to the most important part means, okay, we now look means right now we have reached a stage where developing IoT devices should not be an issue, right? It's a done deal. Means it's I'll not say it's very much easy, but it's a done deal. Means you can do it you can do it. There are manufacturers who can do IoT devices for you. You can simply search for design for manufacturing providers over here, right? So as per me, means this is how I have divided the IoT application. One is pre-harvest, when somebody is doing farming. One is post-harvest. After the farming, when they harvest, they store it somewhere, they transport it. So the applications can be divided in pre-harvest, post-harvest, and in agri-allied sectors. So there are multiple agri-allied sectors, for example, asset tracking or livestock or greenhouse or agroforestry or fisheries, right? Or aquaponics or hydroponics. There are multiple sectors. Means I might not be able to cover all of them, but yeah, I have tried covering most of them over here. So we'll start with the pre-harvest side. So pre-harvest, again, I have divided that thing into three or four part. Pre-harvest, one application can be micro weather monitoring. Now you can ask, okay, what you will do with micro weather monitoring? You can do multiple things when you are monitoring the micro weather. And when you say micro weather, is more like the weather at a farm level. And there can be different weather parameters, right? As I mentioned in the starting from temperature, humidity, pressure, rainfall, wind speed, wind direction, soil moisture, soil volumetric water content, soil electrical conductivity, soil temperature, leaf wetness, solar radiation, lux also, right? So these can be variables in the micro weather monitoring. So micro weather monitoring is one application of agriculture. Now, whatever variables you are capturing from micro weather monitoring, they can be utilized to do multiple things. Second application can be smart irrigation, right? Smart irrigation. Now, smart irrigation, there can be multiple models of a smart irrigation. One model can be that you are monitoring the soil moisture and you are simply controlling the pump and then the valves. But that is being done locally. You are not sending anything to the cloud. Other and you are configuring your device over there. Okay, that turn on the motor if the soil moisture is less than this, and turn off the motor if soil moisture is more than this. You can make it more complicated. You can allow the user to configure your system remotely also, right? And at the same time you can send the data from these sensors to the cloud to show them also. You can also allow user to turn on the motor and turn on the valves remotely also, right? Now there can be different ways of implementing smart irrigation. It depend upon what probably user ever ask or what kind of product you want to push in the market. Third thing can be soil testing and management. There are multiple companies right now who are using a spectroscopy, right? Spectroscopes right now to figure out what is the NPK and soil carbon or EC levels in the soil, right? There are a couple of companies in Kanpur also. I think Professor Jayant has, not Professor Jayant, in IIT Kanpur, they had made a device which can figure out the soil components in 90 seconds, and they have outsourced that technology to some company, right? Krishi Tantra is again, I think, one company based in Hubli. Uh, if I'm right, yeah, Krishi Tantra is a company who do soil testing again, right? That is the third application. Fourth application can be image based application where you are trying to figure out the insect and diseases, right? Now insect and disease forecasting can also be done using micro weather. So there are different models which the research institute have published which correlate the occurrence of disease and insect with respect to micro weather or the soil moisture, right? So as per me, these are few application in pre-harvest. Going to post harvest, again, same thing, that asset tracking. Suppose you have done the harvesting and you are sending it from the farm gate to a cold storage. Now you need to monitor where your truck is. So that is more like asset tracking, and that can be done using GPS, right? If whatever you have harvested, it can be impacted with the outside temperature, you will also need to monitor what is the temperature inside this truck, right? Inside this refrigerated truck. So that is one use case. Second use case can be silos monitoring. I don't see too many silos in India, but outside India, wheat and grain is used in stored in big silos, and there people want to monitor what is the level of the storage or what is temperature humidity over there. That can be one application of IoT in agriculture. In post harvest, third can be same. It's very I think most of people know that cold storage monitoring and control. Inside cold storage, people store a lot different kind of produce, right? So they need to monitor, they need to maintain a specific temperature inside cold storage. So that is one thing. Dairy monitoring again, same thing that when you are processing the milk in a dairy processing unit, you need to monitor what is the temperature over there, what is the flow of milk. So you can monitor flow, you can monitor temperature, right? So these are few applications in the post harvest. In the agri allied sector, greenhouse, same thing. That why people do cultivation in greenhouse, because they want to make sure that that they are maintaining the internal environment. So you can monitor starting from leaf wetness, lux, temperature, humidity, right? So different variables you can monitor inside a greenhouse. Forestry, if you're doing trees which are very costly like sandalwood, right? There's a possibility that somebody will come and cut it, right? So you want to monitor the vibration in the sandalwood trees, right? So you can have vibration sensors, you can have LoRa based devices or Zigbee based devices. There's one very famous company right now which is doing this early forest fire detection, right? So they are doing the same thing, that they have these solar powered devices which can monitor the air, some of the air variables, and they can tell, okay, is fire starting at some location in a specific forest, right? So that also come under forestry. Dairy I've discussed earlier. Livestock again, same thing, that a lot of people has came to us in the very starting, that can you monitor the number of livestock which is passing through a gate, right? So it can be done through RFID, or it can be, or you can make these temperature and humidity devices, temperature devices, which can go on the neck of the livestock, which can monitor the different very important variables of the livestock when they are ready for mating, or something like that, right? Agriculture asset monitoring, it means there are multiple companies in India who are monitoring their assets using GPS devices. Are the asset moving or not? Is the asset in use or not? Am I running out of time, Amit?
Yes,
How
sir.
much
Yes, sir.
time
You
I
can
have?
take, if you could summarize in next 2 minutes, sir.
Okay, sure, I will do that. So asset monitoring is one thing. Then fisheries again. In fisheries, in aquaculture or hydroponics, you need to monitor variables like DO or pH or electrical conductivity, right? So agri Allied sector, these are few applications. Then this is some information about what we in Yuktix do. So the left hand side is an insect trap camera. The middle one is the crop view camera that we have developed in-house. And all this we have developed in-house, solar powered, battery powered. The right hand side is the weather station. This is some information about how smart irrigation can be done, right? So you can have different devices deployed in different locations. They can send it to cloud. You can have different computation, and then you can tell the farmer, okay, when they should irrigate, how much they should irrigate, based upon different variables. This is more like on the insect monitoring using camera that we have developed in house. That okay, you can have the count of the insect that are coming to a specific location using pheromone sources. You can correlate that intensity with weather, and then you can develop a few algorithm that will tell you if the insect is attacking a specific crop or not. Then again, same thing, the devices that we have developed in house and the photo that these devices take of the insect or the crop. I have not added the crop one over here. The asset tracking thing, that what kind of variable we can monitor: GPS location, fuel level, driver identification, machine health. For the hydroponics or vertical farming or aquaculture, variables can be temperature, humidity, lux, CO2, wind speed, water pH, water EC. Again, the idea remains same, that you sense, you send it to cloud, you compute, you analyze, and then you put the information in front of user that he can utilize. For the greenhouse, for the greenhouses, for the monitoring side, for the this is more like the our WSN deployment, where we have this wireless sensing devices deployed in different location communicating to a gateway. So here is for the cotton that we have done for soil moisture monitoring. Uh, for the poultry farm, same thing, that wind speed, wind direction, images, ammonia, CO2, and then you send to cloud, and then you can control the temperature, heating, and the fan over there. So with this, probably I will conclude my presentation. Thank you very much.
Yeah, thank you so much, Shalendra sir, to explain with simple language what is about. It means the IoT, what are the different components are associated in a single device of IoT, and the mainly the role and the applications of the IoT. With a very beautiful examples, you explain in which areas this IoT can be utilized. So I hope the attendees, mainly there are maximum startups are there who are working in a different applications based on the IoT technology. They got good insights from your session. I would request to participants, if you have any questions, you can put in the chat box, or you can click on the raise hand tab so that directly you can ask the questions to the speakers. We will allow you to unmute after the second speaker session. But before that, I would request my colleague to Anupam, you can now introduce our second speaker.
Yeah, thank you, Amit. So for the second half of the webinar, we have with us Mr. Benjamin Raja, sir. Mr. Benjamin Raja, sir, is a visionary entrepreneur having more than 30 plus years of experience, and he's the founder and CEO of FarmerGain, a pioneer agriculture technology company with a deep passion for sustainable farming practices and drive to positively impact the agriculture industry. Mr. Raja has been instrumental in revolutionizing how farmers approach cultivation and food production. As the CEO of FarmGain, Mr. Raja spearheads the company's strategic direction, driving growth and expansion into new markets. He strongly advocates for sustainable farming practices and the adoption of precision agriculture techniques. His mission is to empower farmers with data-driven insights and enable them to make informed decisions to increase yields, reduce resource wastage, and ensure environmental sustainability. In addition to his responsibilities in AgAM, Mr. Raja actively participates in industry events and conferences where he shares expertise and insights on sustainable agriculture, technological advancements, and the future of farming. His passion for creating a more sustainable, efficient food production system has inspired many and continues to drive the success of FarmerGain. With this brief introduction, I'd like to hand over the session to you, sir. Over to you, sir.
Yeah, thank you, Mr. Anupam. I'm sharing my screen now. Yeah, hope you can see my screen.
Yes, sir. Your screen is visible, sir.
Okay. So, good morning, everybody. My name is Benjamin, and our company's name is FarmGain. So, quick introduction about me. I used to work in Honeywell, specifically in the R&D segment. So, the company being into aerospace and industrial automation, my short exposure to agriculture in especially the Western countries in Europe and in the US sort of made me compare their practices with practices in India. And I saw the huge difference in productivity between West and us. And that was an inspiration for me to start this company, FarmAgain. And the reason for FarmAgain is to indicate that there is a need to look at farming from a different perspective. And the harvest the unharvested is a registered trademark, tagline. And the meaning of that is there is a lot more can be harvested which we are still not harvesting from every plant. So that's a quick background. So what we are trying to bring to the market is smart agriculture practices using IoT and artificial intelligence. And the name of our brand or the product brand is Growtron, which is intended to be an autonomous precision farming technology. This is specifically into farming. Not catering into pre or post harvest or farming. It is specifically into farming. So a quick look at the science. So we all know photosynthesis is the process in which a plant takes its energy from sunlight, and that energy is used for the growth of its different parts. But then for that to happen, the plant has to have the components that you see on the right side. So the first three of them, carbon, oxygen, and hydrogen, are non-mineral sources. So carbon comes from carbon dioxide in the atmosphere, and hydrogen and oxygen are taken from the moisture at the root zone. And they form, interestingly, 96% of plant's requirement. So assuming these are made available, and if all other minerals are available in the root zone, and a condition called air-water balance, which means the soil is neither extremely wet nor is it dry. So a right condition of soil moisture. So when all of these conditions, sunlight, or availability of non-minerals, minerals, and right air water balance at the root zone, the plant has to perform and it has to perform at its peak. So that's the science. So we focus on the science. This is how we sort of coined the technology. So the blocks on the bottom left, think of them as different zones or plots in a farm. Each of them will be fitted with a few sensors. The basic necessary sensors will be the ones that can measure soil moisture, either volumetric or tensiometric, and the temperature. And also, we measure the ambient temperature and the humidity. There is a whole lot of sensing that is possible, which I'll show in the next slide. So what the system does is it reads these data every, let's say, 15 to 30 minutes. And while it reads the data from the sensors, it also pulls data from weather stations. There could be a local weather station from where the data can be pulled, or it could be weather.com, IQweather.com, in the absence of a local weather station at the farm. So it'll pull all kinds of data that have any relevance to the soil moisture. Say, for example, wind velocity or sunlight, or a few examples, parameters that can affect soil moisture either positively or negatively. So such data will be taken and bundled with the data from the sensors, will be stored in cloud, and um, that is one set of data. The other set of data is the actual irrigation history. How long irrigation was given for each of these zones. So when you combine these two data, there is a possibility that we can take it through artificial intelligence, where the system can learn from the weather pattern, from the soil wetting and drying conditions, and the irrigation pattern, as to when the soil moisture is likely to dry up. And once that prediction is made, then the system can be trained again to make another prediction. So when, let's say, if the first prediction is the moisture is fine now for, let's say, zone 3, and it is likely to dry up at 4 o'clock. So the next prediction will try to predict when and how long an irrigation has to be given in order for the soil not to dry up. Say the prediction can be today at 11 a.m. for 30 minutes, or two irrigations, one at 11 and the other at 3 o'clock for 15 minutes and 30 minutes each, something like that. So once these predictions are made, then the IoT devices that are in the field, which communicate through LoRaWAN, can actuate the valves and also the pumps, so that the irrigation can take place and the soil drying up can be prevented, and the soil root zone moisture can be maintained at a certain specific range all through 24 hours. And while that irrigation has been triggered, if there are some nutrition to be supplied, imagine these tank icons as the tanks where you keep the stock solutions. So the right stock solutions will be injected into the main line, and it will be measured. Actually, if it is supposed to be 2 kilograms per acre, depending on what the dilution is, the system will measure the right amount of liquid and then inject it. So therefore, if you now compare with the previous slide, the soil moisture, or in other words, the air water balance, is maintained 24/7, and the right minerals are maintained or supplied at the right time at the right quantity, which makes the plants to not to starve and get what it really needs. Therefore, it can perform at its peak. So then, in addition to that, there are a couple of other things that the system can do, which is there are filters in every farm, and these filters can be fitted with pressure sensors, and if there is any pressure variation, the system can detect that there is some blockage and can automatically wash off and clean the system. And in a greenhouse or polyhouse, Grotron can also maintain the climatic condition. It can run foggers to maintain humidity. It can run fan and pad to maintain the temperature. It can run air circulation fans, operate curtains based on the lighting conditions, and even inject CO2 if necessary. As we all know, in India, the grid power there is always disruptions. Therefore, especially the high-end farming with people who do vertical farming or polyhouses, it is a common practice nowadays to have power generators. In which case, if there is a power failure and something needs to be done, let's say temperature control has to be done or some irrigation has to take place, Grotron can automatically turn the genset on, do whatever needs to be done, and once the requirement is over, it can put off the power generator. And the other interesting thing is we built these IoT devices all in-house, and they are, like I said before, they can communicate using LoRaWAN. Actually, they can communicate using LoRaWAN, Wi-Fi, and Ethernet, Ethernet PoE as well. But then in large farms, we always prefer a LoRaWAN, and they are completely solar powered, which means we have eliminated the need to draw grid power into the field and make a lot of clumsy wiring within the farm. So there is no wiring. We just take a pole which is fitted with the IoT devices and place it wherever you want and be done with that. And finally, for every harvest that is made from each of these zones, a farmer can generate a QR code which will give a complete traceability of the nutrition history, the irrigation history, and all kinds of pest management history, so that a buyer can be well informed about what he is really consuming. And this is really helping a lot of our farmers, especially people who follow sustainable agriculture practices, to make a few extra penny by following by using the farm to fork traceability using QR code. Now, this is like a technical block diagram, and in a real farm, this is how it will be. You have a water source, the water is pumped out of that, taken into different zones where sensing is being done, and from the stock solution tank, you inject the fertilizers again automatically into the pipeline. So these are the parameters that can be sensed. There are some about the soil, like moisture, temperature, pH, EC, TDS, salinity, NPK, pressure. And then there are some air parameters. I've generally mentioned the greenhouse gases here. It can be methane emission, it can be nitrous oxide, things of that kind. And we can measure rain, can find the wind direction, speed, and there are a couple of parameters on water, like flow rate, EC, pH, pressure, ORP, and dissolved oxygen, and leaf wetness, temperature, light intensity spectrum, and of course the voltages, power frequency, and things like that. And also we do measure tank levels. That means these fertilizer tanks can be fitted with ultrasonic sensors or radar, and that will measure the quantum of liquid inside, and it will show to the user the actual quantum that is available in the tank. And that is a standard feature. I mean, every time we give a fertigation system, that goes as a standard feature. Anything that is being sensed is being shown to a user through mobile apps, desktop apps, or Android TV apps. And as we speak, we're also developing apps for specific TV platforms such as Sony, LG, and Samsung. In addition to that, it also shows what is happening in the farm. Say, if you look at the screenshot on the left side, the green plots, in fact, mean that the moisture is all fine. All the parameters that are being sensed are in ideal condition. And the brown indicate there is some imbalance which the system will address shortly. And this blue indicates there is some operation going on. It is probably irrigating to this place, or let's say if it is sending fertilizers, it will be in a different color. If it is fogging or operating the fan pad. So each of those operations will be indicated in different color codes. So when farmer looks at the app, instantly he knows what is actually going on in the farm. And it is in fact a completely autonomous system where nothing is expected from the farmer to be done on a daily basis, except to make sure the fertilizer tanks are filled to the right level. Even that, he will be sent a notification and email a week before, a day before, and I think 3 days before. And again, depends on how he configures. So he will be sent a notification saying tank A has to be filled with so and so fertilizer. Please take these many kilograms, mix it with these many liters of water, and fill it. So he will get a very specific instruction. All he has to do is have somebody follow that instruction. So other than that, there is nothing one has to do from a irrigation or fertilization point of view within a farm. And it also sends weather alerts and warnings. And let's say if it is going to, I mean, sometimes these weather alerts are useful. We had a call a few days back from a farmer who was doing cotton, saying your weather alert was helpful. We were able to save our harvest by just timing it. So in some cases that does seem quite helpful. And these are some screenshots just to indicate, there are so much of data you can collect from farm and use it for future reference. I'm not going to present any data in particular, but it is just to let you know that so much of data collection and studying is possible from a farm when we use IoT. So trend lines of temperature and humidity, a whole lot of data. And this is a quick case study we got recently from a farmer. It is a 20 acres of coconut plantation. On 14th of May 2019, the plantation was like this. As you can see, the health of the plants are questionable. And on the 2nd of December 2020, about a year and a half later, the plants have turned into quite healthy manner. So what really was changed? Flood irrigation was removed and replaced with drip irrigation. And then Grotron was installed to take care of the irrigation and fertilization in the farm. So what it did was essentially maintained the right air water balance or right moisture at the root zone, and the right fertilizer was given at the right quantity at the right time, all automatically. So this was the result. So in terms of number of nuts, you can see the picture. I mean, from this it went to this, and then when we did a measurement, there was a good increase in the yield by number of nuts. And when we go by the number of weights, in the next slide, the increase was even better, because in addition to the increase in number of nuts, there was also an increase in average nut size. And this is by revenue. Obviously, there was a good increase in revenue. And what is interesting is, by the way, all these figures are in USD because I presented this to a foreign client. Therefore, I mean, I didn't have time to change this back into INR. So he spent in total about 13.5K US dollars. And at the end of 3 years, not only did he recover all that he spent, he also had an additional money of about $5,500 back on his hand. That is by adding the additional revenue he realized, and the expenditure that he was able to cut short because of IoT installation in his farm. And these are some pictures. Like I said, this is solar powered and communicates using LoRaWAN. Therefore, you can place it anywhere in the field. And this is a farm in Ooty at 2000 meters elevation, 60 acres of farm. This is basically a fully sophisticated farm where there is a drip irrigation for irrigation and fertilization. There are foggers to address in Ooty, early morning you have fog, which will kind of burn the leaves when sunlight becomes harsh in the morning. So what we do is we run these sprinklers automatically to make sure that, and it also has pH compensation, auto backwash. And the other feature that this farm particularly has is they have two wells at the bottom, and the elevation difference between the wells and the actual irrigation tank, which is on top, is about 240 meters. So what we have done is we have fitted all the tanks with ultrasonic sensors, and when the tank, the irrigation tank on top goes below a certain level, depending on which well at the bottom has water, automatically that will be pumped up to the irrigation pond, so that there is a continuous irrigation and people don't really have to walk all 250 meters up and down to keep the tank full. And this is an experiment we did with Tamil Nadu Agricultural University, where on a trial basis, we installed drip irrigation on a paddy field, and used our technology to see how effective the paddy growth will be without flooding. And in fact, the outcome was quite fantastic. You can see the image at the bottom where you see the land completely dry, and can see excellent growth. And what I've heard from the professors there is that the yield recorded from this field was 2.5 times that of typical flood irrigation practice. And this is also an interesting field, the sugarcane, where we were able to harvest 106 tons per acre using the same technology. And this is how a typical farm, fertigation and the backwash setup will look like. All of them have been, all the manual controls have been bypassed and connected to IoT, so that, I mean, no one has to really do anything there, like I said, except filling the fertilizer tanks with stock solutions. And some coconut farms, old ones and new ones. And this mango plantation, it is a 15 years old mango plantation. So the feedback from the farm owner is that the technology was installed about year and a half back, and the feedback is that they never had truckloads of harvest in this farm, and only this year they are starting to have good harvest. So that's pretty much I had to say. So therefore, in nutshell, technologies like this with where IoT is involved, where you do sensing both through sensors and remote sensing, and some intelligence is being used and applied back in the farm, really does improve the productivity and brings down the cost, brings down water usage. We have, on an average, be able to show at least 50% saving on water. So that's pretty much I had to say. Over to Ms. Shanapur.
Yeah, thank you so much, sir. It was really interesting to know what kind of devices you develop, and mainly the Grotron. It's a perfect example that different types of sensors, how the different devices can integrate and give the one solution overall to the fertigation and to the control agricultural management. So with this, I would request to the participants, they can put their questions in the chat box. Already few questions are there. I have also noted few questions. So, and if you want to ask few questions directly to the speakers, you can raise the hands. So I request to my colleague Saurabh, could you please unmute to Miss Archana ma'am as she raised a hand. So Archana ma'am, you can directly ask questions to the speaker.
Hello everyone. My question is to Mr. Sailinਦਰ Singh. Is about how IoT application can be useful for the agriculture engineering and assets.
Agriculture engineering and asset, I think, yeah, I have added one slide on that. So this is more like asset tracking, right? I remember a couple of years back, Assam government was doing a lot of work on asset tracking or agriculture engineering, right? Now there can be different variables that you can monitor in any agriculture asset. For example, if you, I mean, government of Assam was doing mostly on the tractors for tilling, right? So the occupancy, are they being used or not? What is the location over there? So they can optimize the usage, right? For example, if the tractor which is given on rent to one farmer, if it is not being used from last one day, it can be assigned to somebody else. So GPS is one variable that can be monitored on agriculture asset. Fuel level is second variable that can be monitored. Third is definitely the health of the engine, right? Based upon the vibration monitoring. And fourth definitely is who is using that asset with the RFID. So you can have a RFID reader. You can have RFID card given to one specific driver, and at least we can know who is driving that. And again, based upon the usage, we can provide the asset to somebody else on rent basis. So again, there can be more variables also. For example, you can have cameras also, which can keep on monitoring, the field. Right now, a lot of companies are coming up with these automatic weed removers, right, where you actually install the camera just before the weeder. It figure out if the weed is there, and then it removes it. Turn on some kind of weed remover, right? There are certain boom sprayers coming with the camera installed, which can figure out if the spray need to be done on a specific plant or not. So this is more a generic answer. Means I may not be able to dig deeper into very specific answer, but again, it depends upon what kind of variables can be monitored. It can be image or it can be sensor based monitoring.
Yeah, I hope Archanaji you got the answer. So there is very common questions I can say asked by the participants. So I'll be taking that question from the angle of all the participants that IoT seems to be very helpful technology for the any kind of farmer. But when it comes to the cost, whether it can be able to generate the good return on the investment, and what are the crops basically they should look into so that they can whatever the amount they're spending to install these devices they will get it. So if you just roughly can consider a one average acre of the farm, how much would be the cost, and by what time he can get the investment, so like on whatever amount he's spending for the installation of the devices, that too maybe for the crop monitoring, that too maybe for the fertigation, that too maybe for the irrigations. So like maybe Benjamin sir or Shailendra sir, you can take this question.
Yeah, so it's a very subjective question because it depends on the farm's requirement. But just to give a outline, let's say 2 acres farm would spend a minimum of about 2 to 2.5 lakhs to get technology implemented in the farm. And the return on investment, as if it is a vegetable farm, what we have seen over the last 4 or 5 years is that is within a year if it is a vegetable cultivation. And for plantations, usually it is about 2 to 3 years. So there is a return on investment for sure. And there are lots of farmers now who go through the infrastructure fund that is given by the Agriculture Ministry, Government of India. They utilize that to install our technology. So funds are available, and it is definitely, I mean, if you ask me upfront affordability, the cost of technology has to still, it has to penetrate so much to bring the cost down. But there are funds available which the farmers can use, and return on investment is from 1 to 3 years depending on different crops.
Shailendra sir, you want to add
This is
some?
a difficult question to answer. Means we have came across a lot of farmers. Means sometimes it's very much difficult to tell that what has led to the increase in the production, right? Farmer might say, okay, I have done this thing different. I have added this kind of fertilizer. I have taken this kind of seed. So sometimes it's very difficult to quantify that. Okay, what has led to the increase in production or less diseases, right? Benjamin said, means because means definitely they are very good into the irrigation. Irrigation is something that can be quantified because you can always monitor the flow of water going before you install the sensor and after you install the sensor. I think he has covered about the costing. Costing varies from plot to plot, from size to size, from crop, right? For example, any kind of F&B farmers, fruit and vegetable farmers, they're always willing to put in money because in India they have reached a stage where they have seen the increase in production by usual means. Now they want to go from X to X plus delta X. The delta X is something that they can increase, right? So this is where fruit farmers or vegetable farmers are always willing to take because they can clearly see the impact of technology. Means production I can't comment on, to be very frank, because again same thing. They will always ask, okay, I have added this fertilizer, I have added this seed, I have taken this action, I have taken that action. But yes, water savings can be very easily quantified. Up to 25 to 50%, it can be easily quantified. And over irrigation or under irrigation always have an impact. You over irrigate or under irrigate is going to have an impact on the plant production. So the idea is to maintain a specific water availability in the soil. For us, the cost varies from even 15,000 rupees. It goes up to 80,000 rupees also. right? And if you have number of MEs, so again, cost is a bit complicated thing. Means I think people would have come with just one number, but again, that might not stand true for a bigger plot, small plot, for FNB, for the number of what number of sensors to be installed. It's a bit complicated question to first of all to answer with that. Okay,
Yeah,
this can be done in this much.
what I can say, it's totally depends on how much devices, how much size, and what crops. Basically, you are looking into the solutions. Accordingly, the price can be set. So, with this, we'll quickly go to the next question. So, it's related to the only my previous question. That let's say if a farmer has installed 2, 3 devices, and as per his requirement, the crops may get varied. In case of vegetables, the duration for their harvesting is very small. So can the requirement of these nutrients and the irrigation maybe vary as crop to crop and seasons to seasons. So can a single device can be used for the multiple crops, whether it is customized solutions can be provided.
Yeah, I mean, you see, let's say you have tomato on one side and a brinjal on the other side, which have different nutrition plan. What the system will do is, let's say if urea has to be given at 1 kg per acre for tomato, it will give 1 kg per acre from the same tank. If it is 2 kg per acre for brinjal, it is going to draw 2 kg equivalent liquid from the same tank. So the system doesn't have to duplicated for the number of crops. I mean, it is intelligent enough to use the same infrastructure for all the crops.
Yeah, okay, got it, sir. And
You
what
can.
few participants are asking about the pest management, disease detection. I think you both the speakers already explained. I think Shailendra sir has mentioned what are the applications areas where these devices can be utilized. So that answer is already there. And their presentations and contact details also we are sharing to the registered participants of the this webinar. So for their details we will get. We'll go to Shailendra sir. You want to say something before
I
we're going
wanted to
to?
say that the same sensor in the same field can be utilized for different crop. For example, the vegetable growers, they don't do same crop every time. So you
Yeah.
can think it like this, that sensing is one thing, competition is other thing. Competition can be done on same data for different crops, right? So the same sensor can stand true. Means if they are replacing potato with ginger, or potato with tomato or chili, right? Same sensor can work. It's just like on the software side, you have to change the competition for a specific crop. So same sensor, different competitions.
Yeah, I think so. It's a one-time investment for the farmers, I must say. That how much time, sir, like a device can be utilized? If we
device device life, again, there are few part which need to be changed. For example, any sensor that is exposed, for example, when we use TRS sensor, temperature humidity sensor, on a PCB, right? Now that
Yeah,
is exposed to the environment, some kind of oxidation can happen, but that can be easily replaced. Other
right.
sensor, I think we have tried for even 6 years. One is working in IHR still from last 7 years, right? That soil sensor. So
Yeah.
it depends upon kind of sensor you are using. Yes.
So probably I can able to take one more question if time permits. Actually, already over the time. But sir, many agri startups are joined us for today's webinar, and they are maybe at very early stage. They are just exploring the opportunities that how they can integrate these technologies in their solutions. So, is there is any institution or whether your company or maybe the institutions was working just providing the training and guiding them to work on their solutions based on the IoT? If you could inform them, so that will be helpful.
Not training, I think in this era of generative AI, right, with Brad and this chat GPT coming in, a lot of information can be taken from there. Means, in fact, whatever I have discussed, somebody can simply go start punching the question, they will start getting the answers, right?
Yeah.
IoT, as I mentioned, is a bit is a umbrella term. A lot of variables involved in that. It means if anybody want to start working in the IoT field on the startup, they need to first of all identify what field they are going to be. This is what I was saying, hammering the same nail again and again, right? You can't be just like a big company serving every vertical, doing different products. No, you can't do that. Being a small team, you can't start serving every possible scenario, right? You have to start with just one thing. It can be just like soil sensing, or it can be just like image, right? Just image, process that and give the advisory. Don't start thinking of a super app capable of solving all the problem. Not possible at your level. You can't do it. Not everybody is Superman, right? So we start with one very specific problem statement, solve it, put it in the market, get the customer traction, and then down the line after 4 5 years start diversifying yourself. There are more than sufficient users in the world with which you can make 100 crore company. Not required to do 10 100 things to do 100 crore.
Agreed,
One
sir.
thing 100 crore.
Yeah, very true, sir. You should be focused, and then they can think for the more applications in the single devices. I think we will take only the last questions of the session. Mr. Kiran has raised his hand. Saurav, could you unmute him? Kiran Patil, you can ask the questions to the speaker quickly. Hello, Kiran, can you? Yeah, you're audible. Please ask the question. Yes, go ahead.
Yeah, the question is, Benjamin, the ROI question is a follow-up question for that ROI question. Now, I have worked in, say, commercial vehicles earlier, and for any proving, we used to conduct a side-by-side trial for, say, establishing that this is a fuel economy of this truck versus this truck. So similarly, do you have a set that can be for establishing that, yeah, there is a certain benefit for it? Let us say for a small cycle crop like brinjal. Okay, so one plot with this one and other plot with regular methods. Have you conducted kind of studies like this? If not, is it possible to conduct such studies so that the return of on investment that we talked about, that can be very precisely and very confidently established?
Yeah. So the answer is yes, we have done such studies. That was in the years 2017 and 18. We did quite a lot of comparative studies. All the practices are same except for the usage of technology. So, but then post which what we started doing is, let's say if you go to a place where the average tomato production is 15 tons per acre, when we install a technology, we see for let's say 2 or 3 cycles, and take the data and then compare it with the actual farmers' data of the neighboring farms, and also the previous data of the farm where we have installed the technology newly. So in 2017 and 18, we did the theoretical comparative study, but now it is all comparing with the real productivity on a real farmer's field.
Yeah, I hope Kiran, you got the answer. So still a few questions are coming in the chat box, but due to time constraint, we're not able to take all questions. And yeah, many of you are requested to share the presentations and the contact details. Of course, those who are registered attendees for the Saturday webinar, we are sharing their details and the presentations to you over the email ID. So with this, we will be stopped for this session. But before that, I would request to all the participants, kindly give us the feedback. The link is already in the chat box about the today's webinar. And also you can suggest few topics that you want to hear from us. We want to organize from managed side in the future. So that also you can suggest us. Also request you to follow our social media pages to get the regular updates from us, what kind of sessions, the trainings we are organizing in future. So that updates you will get. And last but not in the list, today's speakers that and guiding us on this topic. So thank you all for being here, and we'll see you in the next webinar in the next Saturday. Thanks all. Thank you, sir.
Thank you.
Thank you, Benjamin and Singh. Thank you for joining, and it's very interesting session. Thank you very much.
Thank you, sir. Thank you. Thanks.
Thank you. Bye, Amit and Anupav, Saurabh and Yuvraj. It's a good actually.
Yes, sir. The participants also good, sir. They are in quite interactive also, putting questions also. Yeah. Thanks, sir.
Fine. Yeah. Okay.
Yeah.
Bye.
Bye.
Good day. Saurabh, bye.